So in this video, let's see how we can implement or print a Floyd's triangle using C hash. So a Floyd triangle is basically natural numbers printed in a triangular format where each row has, for example, the first row has one column, the second row has two columns, and the third row has three columns. And they are continuation of numbers starting from 1 all the way until number n. And let's make it dynamic also. So this is the requirement. If I ask the user for the number of rows he wants, we should be able to print that much. So if I happen to run this again, so let's say this time we would want a 3 row, we'll just print a 3 row. So in order to implement this, let's see how we can do this in VS Code. And in order to save some time, I do have the code ready here. And if you just compare this to the previous version where we generated or printed this Floyd's triangle without an array, there is not much difference here in the logic at all. Instead of array, I might have probably taken the variable as triangle, and rows I'm asking from the user instead of hard coding it. And instead of num, I just have current number. The variable is named more elaborately to improve the readability. And if you see here, we have declared a um, jagged array with by telling only the number of rows we want, which is given by the user. We we will go and declare the um, columns dynamically and even assign the value for it. And how do we do it? We just specify the row index and we say new int of so and so numbers. So for example, for the 0th row, there'll be one column because it's plus one. And for the first row, which will in fact have two columns, so it will be 1 plus 1 will be 2. So since we are starting with zero based index, we just need to adjust this to this number to reflect the actual number of columns, hence this plus 1. And this part would just reserve the space for that many columns, but they would all be initialized to 0. But remember, we are supposed to store the numbers we generate into the array. The rest of the logic remains the same, meaning I'll have to go all the way from the first column until the row column. So basically, if let's say we were in the index 2 here, so which basically means the third column. So we'll also go until 2 here. So that means 0, 1, and 2, total 3 columns. So to summarize, this outer loop is controlling the rows and the inner loop is controlling the column, but with an additional condition so that we don't end up using up, all the columns here. In fact, they don't even exist. If you try to exceed this, you might even get exceptions in the runtime. And in the previous program, we were just printing the number. Here, we're actually assigning it. We could have gone ahead and printed it here itself, but then we'll assume this piece of code is only declaring and putting the values in, and there'll be a separate loop which for printing it. So bearing that in mind, we've just separated out the assignment and printing. And of course, we increment it so that starting from the number 1, we then move to number 2, 3, 4, 5, so on and so forth. And this is the usual way we access a jagged array, where we mention the row and column in two separate square brackets, unlike what we do in a two-dimensional array. Even here, even here. And how do we display it? We use the same logic here. We could have used the dot length. You could have used the for each loop here also, but we're just going with a simple index-based loop here, which start from 0 to less than rows. And we are using that expression. Remember, we can find the length or we can find the number of columns in a row by just saying array of row dot length. So this is the expression we saw previously also. So using the same expression, I'm getting the column number here because this is dynamic. I simply don't have a simpler way of doing this because each row, the number of columns varies, and we are going ahead and printing it. Maybe with some spacing here in between, or if we wanted to be even more precise, we could have used another type of spacing also. But let's see how this comes in here. So I'll just say .NET Run. So it'll ask me for the number of rows. Let's say I give something like an 8. So I did get the floyds triangle of 8 rows. So it runs from the integer 1 all the way until integer 36. So maybe we can play around with the spacing. Instead of literally appending spaces in the string, we can perhaps use something like this, or we can even give a 5 and see how that turns out to be. And we'll go back and we'll rerun the program. And let's say this time also I give something like 8. The spacing is a lot better compared to the previous one. So to conclude the series of videos also, we first understood what jagged arrays were. Um, we saw how we can have different number of columns in each row. And then we saw how we could print a floyds triangle um, by simply printing patterns like star and then printing numbers without actually storing them in an array. But then the requirement was to store these numbers which we generate into the jagged array, assuming that they'll be used for further processing. So hence we then saw how we can introduce the jagged array here and dynamically allocate the columns here inside the outer loop, and then go ahead and put in the generated number into the jagged array and eventually printing it. We could have actually gone ahead and also printed a floyds triangle, a more refined version, like probably containing only even numbers or odd numbers or any series that we can generate with the entire structure intact and only the logic required to generate that number being changed.